Sage from Jacobs LLC, acting like an idiot to make you smile, because we're going to talk about some stuff like that fast music right there. We're going to work on some coding techniques, and it's going to be real quick too. There's simple techniques to make it so that your code can run a lot faster, and some of them only make it a little faster, but when you apply it systemically, completely throughout all your code, it's going to work wonderful. It's going to be a benefit to you. And everything I'm going to tell you, you can research and find that I'm going to be dead on right about everything. Why? Because I think I know everything? No. It's because I've worked with this stuff, I've read this stuff, I've studied this stuff, I've read the Intel books, I know how the CPU architecture works, I know how these simple techniques can make coding so much easier for you. Not easier. No. Faster. Not coding it faster. It executes faster. That's what we're talking about. And I'm also going to cover another technique too that I use just to share it. This one's one of those ones that's 6 to 1, half a dozen to the other. But about coding, usually you want to have single entry and single exit from the routines, procedures that you write. So I have a way that makes it very itemized and very like little blocks that are real easy to read. You can visually see them, and they're real easy to follow what's going on. Okay, and we're going to cover that too. But for starters, I'm going to show a very simple technique that can make your programs faster just by employing them all the time. The more you do it, the faster you will be able to benefit from CPUs that today have a prefetch cache that looks at the computer instructions that are about to come and predicts where it's going to go. How does it predict it? Does it have a little magic ball? No, it doesn't. We're going to talk about this real quick here. There's no magic ball in the computer. I know this because when I use the ATM, it only gives me money that I have. If it was magical, I'd get all kinds. Okay, here we go. When you're making a simple logic statement, right? Every programming language has if A equals something, whatever. The point is that we have an if. We're going to have some sort of expression and do a response, and then we're going to have an else. Okay, so we're going to say if A equals 2, then do something. And then there's else, do something else. I can't spell. I can't spell at all. Sometimes. Okay? Do something else, and then that's the end of our if statement. Okay? This is a very basic construct. This is stuff that every developer will, at least in one form or another, recognize and be able to read top to bottom, no problem. Which is good, because I'm going to tell you something that matters now about this. I'm hoping you understand this. When you go to the if statement at the top, see where it says do something? When you're coding, if you want that prefetch cache to work in your favor, you want to make it so the instance that happens the most often is right at the beginning of that if statement, the do something part. So if you have something that happens less often, you always want to put that on the else part on the bottom, because that way when the CPU's basically predicting how the code's going to flow, it's going to be correct more often than if you do not use this. I don't use it all the time. I try to use it all the time. But I also have a little technique I'm going to tell you now that actually just contradicts what I'm telling you for speed. But I wanted you to know about this, and I do this. But when I have code that I really need, like when I'm writing quality business software that needs to be very clear when something goes wrong, what went wrong, and a way to find it, there's a technique I use. And I'm gonna share that with you next. Okay, but this is the first thing: the predictive cache code execution on most CPUs, AMD and Intel anyway. That's how they do the predictive stuff. The first option on the if statements, and if you broke it down to assembly language, the machine code, which is what the computer's really talking about, the first instruction is assumed to be true. That's how it predicts. It assumes all the first ifs, the conditions, are true. That's how you can change it in your code. This applies to everything, even scripting languages, because they're going to boil down and ask the same question to the computer, even though they're a few layers up, So any language you're using, this does have an impact. Like I said earlier, though, if you do it just once, it doesn't do anything. I mean, it doesn't help you a whole lot. If you do it all the time, you're going to get a speed benefit, and you're not going to be invalidating the prefetch cache all the time, because your most frequent things are always happening down here. You understand? Okay, excellent. I knew you would. Okay, so the next thing is this technique about making code that's single entry, single exit. It works with exceptions. I don't recommend using commands like some basic languages have, like where it's on error, just resume, which you can use in emergencies, or on air, jump down to somewhere when you have an error, because it's not always obvious. You'll have an idea what went wrong, but you won't necessarily know where it went wrong, and that's why I don't recommend using that technique. Check this out. I use Pascal, so the language is going to look like that, but I think it's easy enough to read, like a version of BASIC, that you'll be able to follow along what I'm saying. It's pretty simple. If you were to have a function, for example, test, okay? We're going to begin our function, but we're going to have one variable here. Okay? It's basically okay with a B in front of it, for B for Boolean. Okay, Boolean, true, false. All right. So we have that whole thing going. Now, when we're going to do something, I always start off by initializing the be okay to true. Now I'm going to start making cut and pastable blocks of code that I can move all over my routine, change the order of them, stuff like that, and they still will do what I'm talking about being single entry, single exit, and being able to be very particular about catching errors where they happen. So let's see. If be okay, then begin. Okay? You can have all the code you want here, but once you get to the part where there's a possible problem, maybe a function or whatever, okay? Possible problem, we do this. Be okay equals possible problem. Okay? There we go. Then I do this. This isn't rocket science. It just works for me. So I'm sharing it. If not okay, then log error. One other thing I do, if I'm making my own logging routines, to make it so I can find this stuff quickly with search tools like grep, G-R-E-P, text searching tools, or just searching through it with an IDE, your integrated development environment, whatever. You're using Visual Studio or something like that, or you're using Eclipse or Notepad or something. Okay, what I do is I'll actually have 2 parameters, or maybe more. I actually use a lot more, but I'm not going to get into that. We start right here. I actually do something that's actually like this: month, month, day, day. I'm sorry, month, year, month, day, day, and then hour, and minute. Okay, so I have a unique code. I just use the current date and what time it is, and I use a 24-hour format, like military time or whatever. So then I would actually have my message. Okay, this way I can I have single entry, single exit. Because if you notice, if I paste this, I just want you to look at the code flow now. Look at the code flow. No matter what, if there's a problem anywhere, it's going to skip out and fall all the way to the bottom of your routine. No matter what, I'm going to be able to log each one of my issues where I have one. And with this error handling here, I'm recommending you write your own logs, or maybe have something even go to the screen that says such and such a code with your message on the screen. That way, if a client calls you up and says, hey, I got message, I wrote it down, it's message 217 da 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 da, you search for that puppy, you're going to find it. And by using the date and time, you're not going to have to worry about duplicates. Back in the day when I was first starting, I used to make up my own error codes. Like 1,000 to 0 to 1,000 meant this, and whatever. I would use these numbers, but they don't really carry over that well, and weren't necessarily unique. I find that this technique is extremely unique because it's usually not the same. Well, we're always moving forward in time, right? So it works out pretty good. So this is just the way of doing the one-way through. And if you have a try-error kind of thing, like a try-catch routine that you want to see or something like that, I'm going to kill this line down here. And I'm going to, well, no, I don't know. I'm running out of room. I can switch the font a little bit. I'm trying to get enough room to put in a try statement here so I can show you. Maybe just a little bit more. So let's see. All right, so let's say you want to do a try statement. What I do is I set the OK back to false, even though I just came in here. I might do a try. This is useful for, I think think possibly JavaScript, most likely Java, and definitely C++, is and free Pascal too. You want to do like try your code, your code here that might blow up, might die hardcore, okay? And then underneath it, I put be okay equals true, because if it executed the first one, I'm going to come back and not have an issue. Because usually there's a catch of some sort to catch your exceptions. Catch exception. And you can handle these, sometimes there's like a list of things you can do, and you can, from each exception you can do different things, and you might have a different log entry for each one of those things, and that's fine. But what I'm trying to show here is that when you get past your finally, or whatever it's called for your programming language, and you actually get past your all that try catch stuff, okay? And remember, we're dealing like this. The same system will work. So you can still use exceptions and have the same blocks. And when I talk about the single entry, single exit, there's not only the benefit of the logging, I can move this in any order. I can move these blocks around. They're very visible with just having a simple blank line there. And I can move them all over the place and rearrange that code, and it's always going to fall down correctly. That's why I bring it up. That's why I shared it with you. And that's pretty much it. This is a short video. So that's it. I'm Jason Sage with Jagus LLC. Go to our website if you'd like it, jagus.com. And don't forget, we've got little icons at the bottom of our website. You can see more of the YouTube videos. I don't know how you got to see this one, so you might not be on YouTube. But if you want to see what we have coming, next videos, what's new and all that, just go to jagus.com, check us out. It'll bring you right to the channel, and you're good to go. And don't forget to look at our products. We actually have a lot of free stuff, downloads that you can just play with, like a timer, an editor. I got this thing. Just check it out. All right, so have a good day.